Let me find my files somehow. Oh, and I wanted to make this hands-on, right? So let's go here. Actually, before each part scripts, there we go. Then I'm gonna convert this to a zip file, and I'm gonna upload this. If I do that, now I'm gonna upload this to Canvas. There we go. And we're gonna come to here, I think. Just the size, okay. There we go. So the scripts that I'm using today for the hands-on session, I already upload them on Canvas in a zip file with the data set and everything. You can try that at home, or even right now, it's up to you. I think most of the script works, but you know, with me creating a script, you never know. So I wouldn't put my life over it. There are some parts of it that probably gonna throw an error, and I just forget to look at it and fix it. But it's close enough. Now let me also open RStudio. Okay. So I have to switch between these as I move around. Okay. Let me do this. Okay. Those of you who are online, can you see the slides? Okay. All right. So, what do I want to say? We are still in the process of recruiting somebody as a TA. So as a result, I'm supposed to do all of the homework checking and stuff. And right now I've got like 200 pages of papers to write. So with that in mind, I am behind on every other thing, including answering emails. I decided to extend your homework due deadline to next Friday. I remember these stuff. I should not say this, but these stuff are not. There is no hard limit in here. Okay? In this class, there is no hard limit. There are only 4 homeworks. 2 of them are already released. Okay? So if you need extra time, just let me know, and I'm more than happy to accommodate this. The important thing for me is for you to go and do that thing. And as you are going to see with the other 2 homeworks that we're going to release in following weeks, they are designed to force you to learn to do something. They're not designed to find a way to subtract marks from you. You're going to see it very soon. But with testing, it's just designed for you to play around with big data and try to understand what's going to happen if you get rid of a couple of the categories and see how does the clusterings are going to change. and then also try to get rid of some of the features or some of the data points in your data, some of the columns in your data. And by doing that, see how those can impact the overall clustering that you're going to see. Okay? So it's all about understanding the impacts of the categories and the impacts of the features that you're using to separate these two different groups. In terms of the data set, lots of you ask this question, where to get the data sets. I would say, if I were to do this, I would go after medical data. Not because I've got a lot of background in medicine, but because they come with a lot of samples, and each sample comes with a lot of features in it, a lot of readings. Okay? They do a lot of tests, and each test has a couple of columns, and that's what you want. You want something that is large dimensional in terms of the number of features you get, and a lot of samples. In order of the minimum is an order of a couple of thousands, but realistically, you should be looking for something like in order of a couple of tens of thousands as the samples. So in terms of the rows, so you need something with a couple of tens of thousands of rows. And 20 to 50 probably columns. Okay? Yes?
Can I sum up that real quick?
Yep.
So a lot of the medical data I was running into, like I was looking at some cancer and diabetes sets, the output was binary. Either they had it or they didn't. And I know you want us to have at least a couple classes in our
yeah, that's not good. But let's say, for example, you've got a cancer, and then you can ask, okay, what stage cancer is this?
Okay.
Right? Those numbers
Okay.
can be useful, but 0 and 1 really, no. It can, well, no, it cannot be useful really. Because in that case, then there's just two categories, right?
Yeah.
That's not what we want. We want something that has multiple categories. Now, if there is 1 or 2 columns out of many, or like that, that's all right. Okay? But if everything is 0 and 1, then no, that's not an answer.
Okay.
Okay? Cool. Remember that I said a lot in the class that a huge amount of time is going to be spent on just getting to the point that you can actually play with the data. So loading the data and making sure that everything is correct and there is no noise and everything. A lot of time is going to be spent on getting that done and getting to the point that you can actually pass your data to a function and see how it looks. All right? That applies to this practice. You're going to get this data and you're going to figure out that there is something wrong with it. Either you cannot open it or it looks funny. And if you just load the data and just pass it through a testing function, then you're probably missing a lot of information there in terms of some bad readings and so on. So if you're opening an Excel, and opening some sort of XLX or CSV file, make sure that you open and take a look at the number of rows that that one has and the number of columns that it has. And make sure that when you load the data in R, all of those columns and rows are actually there. Lots of times, R doesn't throw an error and just load it, but it loads up to the point that it didn't have an error. After that point, it just doesn't load anything. And you go and imagine that everything is okay and do lots of stuff, write a couple of hundreds of lines of code, and then later on you would figure out that, you know, it's just 10% of the whole data. The rest of it isn't coming through. Okay? So make sure you check, learn to check every move that you make with the data in this example, in this homework assignment. Any question on that? Everybody's relaxed now? Yeah? All right. Let's move on. And I promised that I'm going to do some hands-on session, and this is one of them. And the next two on next week, which are going to be on ggplot2, are also going to be completely hands-on, hopefully. I just have to create the videos for them. So this slides again remind us to be vigilant with our health, cover our coughs and wash our hands and stay home when we are sick, and try to prevent touching your eyes and nose and mouth. This one would remind you that if you're interested to be part of this student outreach of ACM, send me an email and let me know. So we were talking about the differences between bar chart and column chart, right? And we wanted to create this. This is something that looks pretty simple, except that it's not that simple. It's quite complicated to do. There are several shades of colors that you see here. And then there are some additional information here and there. Then there are different bars with colors there. And then these labels are not normal. And we want everything to look exactly like that. We want to recreate this picture with all the content, not just the bar. We want this to be presented exactly in here, and those other lines presented exactly where they are right now. Okay, so this is what we want to do. This was coming from a survey that they done, I think, in how many? It was in 2010. It was carried out in different countries, and the question, the thing that they were after was how many % of the respondents agreed with the statement of I definitely believe in God or a super being. That was their question, and what you see is basically the response that they got on 20-something countries, and you see the name of the countries there, so there's no point for me to read them. You already have this quote from the previous lecture, but let's walk through it step by step and see what does this look like. You can actually get the data from Open Mind Journal website, and then you can just enter it manually into an XLSX table if you want. This includes 24 countries. So I already color coded this so that we can go through it step by step, and so that we can actually look at different sections and talk about each section separately. But let me take a seat. Sorry. All right. Let me bring this down. Okay. So one thing for you guys to notice is, even though it looks like very simple, but the way it's using color is interesting. There are multiple shades of color presented there, but these colors are in such a way that the bars are still pretty much distinguishable. So they didn't go and use some sort of shade that would contradict with the actual bars. Okay, now let's start. So here it is. The script basically begins by setting the window size to a width of 9 inch and the height to 6.5 inch, right in here. So what's happening in here is, first of all, it says this is going to be the name of the file that I want you to create. Unlike the usual graphics where you're creating a figure on your screen, this is not what this thing is doing. This is actually creating a PDF file that is going to hold this picture inside it at the end. Okay, so this is going to be the name, and it's going to create the PDF file using this command. It's saying that the background should be gray 98. The name of the PDF file is what is held in this variable, which we define here. The width of this file, this page in this file is going to be 9 inch and the height is going to be 6.5. Then we are in the next one in here using the par command. We are setting the outer and inner margins using OMI and MMI. So OMI is basically setting the outer margin. The MMI is setting the inner margin. And we are also setting up the distance of the distance of the axis label using MGP. So if you look at this, you would notice that the left margin in here is basically chosen a little wider. So we have more space for the labels. Data are basically coming from that XLSX file called ipsos.xlsx. And we are basically reading that and returning whatever that we read, that table, into Ipsos variable that we created for ourselves in here. Then let me clean this thing up. Okay. So that's where we are. We're reading this one. Then after this, what we are doing is we are sorting the data. The way to sort it is to call this order function. We are sorting this on the basis of Ipsos, the column that is named percent in Ipsos. Okay. So, but one thing to notice is that this will give you some indexes. This bit is going to give you some indexes, but then notice here, there is a comma and there is a space. So we are saying in Ipsos, this is going to be the new order. And we want to basically reset the order for every single row in Ipsos. Right? So by putting a comma and this space, it would basically let R know to basically reorder every bit of data that it has inside that Ipsos table, all on the basis of the order of the present, the percent column. And then we are returning all of that to a new table called sort Ipsos. So that's the one that we are going to use moving forward. Now, I don't want to keep writing sort.ipsos dollar sign and the name of the column that I want to use. I don't want to do that. That's just too much. So I will just attach sort Ipsos into the memory. Now, moving forward, I don't need to say sort.ipsos, for example, $percent. Instead, I could just say percent, and it knows and goes and search for it inside the sort.ipsos before throwing an error and say that you don't have percent. But when I do that, then in return, I can basically pass percent to this bar plot directly. Make sense? Yes? No? Okay. So one thing is that bar plot basically plot the bars from bottom to top, and this is going to be against our intuition, but doesn't really differ from the way that a spreadsheet software actually works. So Now using this, oh, I'm confusing myself. Sorry, let me get rid of these. Okay. Now using these plot command, I can actually draw what you see on the screen. So we were supposed to create this, but so far we started with something like this. Now there are a couple of settings that I've done in here. The first thing is you can actually use the bar plot for both plotting a bar chart and a column chart. In order to separate these two from each other and let all know what you're after, you can set the horizon to true or false. Okay, when it's true, it's going to create what you see on the screen. It's going to create this one. We are going to need you're going to need to hold on to this bar chart somehow, because later on we need to assign the some extra values and also labels into it. So because of that, we are returning the whole thing to this variable called x in here. So x is going to represent this object. So first of all, the percent in here is basically holding on to all the values that is gonna drop. So technically, you can have more than one variable to be passed to it. But in here, we're just passing a single column with all of the percentages that we want to use for creating the bar plot. Then after that, we are suppressing the labels in here. We are forcing that to be false, so that it doesn't automatically go and add the labels. We want the labels to look different. If not, if your percent already has attributes for names, and then you said names.argument true, then those attributes automatically are going to be drawn as the labels. Does that make sense? We're going to see an example of this soon, in the next one that we are going to do. Then the other thing is, what else do we have? We've got border set to an A. Which means that no frame are going to be drawn around the bars. And then the value of the axis, the x-axis is going to be within the range of 0 to 100, and the bars color are going to be gray, all of them. And the last one is this one. The font size in here is basically reduced to 0.85. And that's it, really. There's no other settings. Let's go to the next part of this code and see what's going to happen in here. So, oh, we already done that one. Okay. This one. Okay. Now we've got the opportunity to individualize the missing elements before adding them. First, we are going to start working on the labels for the bars. So to do this, we are using some sort of a loop that is going to run through every value of country and then changes the font to Lato black if that country is Germany or Brazil. Can you actually see that? Yeah. I'm not sure if I can magnify this. Better? Yeah. Awesome. All right. Sorry. Okay. So that's that. That line would basically check to see if the country is variable value that holds, which is going to be the name of the country, is going to be either Germany or Brazil. If it is, then it's going to set my font to Lato black. Otherwise, my font is going to be set to Lato light. That's all there is to it. Then it's also basically one by one. After doing that, it's just going to add the names as a text. Okay. So the actually both the names and the country names. Sorry, the country name and the percent. So it's going to add the country name and the percent value using horizontally positioned at coordinates of 8 and 35. I need to use this 8 and 3.5. Sorry. Then the vertical position is going to be achieved by referring to the object X in which we previously saved the results of the bar plot function call. So again, let me zoom in. So we already set the value of for the X as 8 and 3.5. For the Y, we are getting the value from the object that's holding the bar plot. So if we look at the previous slide, in here we return the bar plot into X. I'm not sure why I can. Okay. No, doesn't let me to draw anything. Okay, so now we are looping into this, and we are basically using the index to access the Y value from that X. Okay. Then R is going to automatically extract the required value from the object, meaning the vertical position of the bar. And since the X values are located outside of the actual chart, we have to explicitly enable the labeling outside of the chart, and we are going to do that by setting XPD to true. Oh, I don't like this. You don't even see my marker. Okay, there is no point to do that. Okay, there we go. Then the other thing that we did is that we also specified right justification by setting adjust to 1 in both of these. And we set the font size to 0.85 on both, setting 6 to 0.85. And then we are obviously setting the font color for whatever we are writing using my font. So obviously, if this is the country that is either Germany or Brazil, then it's gonna the font color is gonna be Lato black. Otherwise, it's gonna be Lato light. So by doing this, these two are gonna stand out, and everything else is gonna be a little bit faded. So that's it for the brown section. Then we come to the purple one. Now what we want to do is to basically plot the background areas. In order to do that, we're going to use the rect function, which is going to place a shade of blue in different alternating transparencies over the bar chart. So we are going to create in here, there are 5 of them. 5 of these 1, 2, 3, 4, and 5. These 5 vertical rectangles are going to help us to recreate those shades that we want to put on top of these. We are talking about here. I'm sorry. I keep forgetting to turn this thing off. Sorry. So that's pretty simple. It's just a simple rectangle. All we are doing is we are basically setting the color in here, and we are using different colors. So let's notice these two. So we are basically alternating on the color shades, and we are setting the border to an A because we don't want any border. The locations are set manually. So these are the 4 corners, sorry, the 2 corners, XY and XY of these rectangles. I'm going to magnify them a little bit to help you see. There is really nothing else there. It's very simplistic. Then after that, we get to the point that we are creating my value and my color. So in order to maintain clarity, we are basically using RGB function to assign the color specification to a variable that we called myColor2. My value 2 only contains the respective person value at the position of the Germany and Brazil. Otherwise, all its values are going to be set to 0. Then we reach to this point that we've got x2. There we go. So it basically creates a second bar plot that complements the existing bar chart with the add equal t, meaning add equal true. So it basically goes and sit on top of the existing one. What this helps us to do is that to repaint this, and what was the other one? The 5th one, and this one. So, sorry, we set all other values to 0 in my value. So even though we are plotting them, there is nothing to plot, okay? And we are basically plotting every single one of these, and all the colors are set to look like this color. But realistically, because all the values are 0 except for these 2 bars that are magenta, I think that's magenta, right? Then it would basically just draw those 2, and everything else is going to be ignored. Then after that, we get to the point where we are playing with arrows. And okay, so did I miss something? There's really nothing to it. The axis is false. There is no axis. The font size is 0.85. Then the color is set to myColor2. Then the X limit is set to 0 to 100 like the other one. There is no border around it. It is horizontal, and there is no names. And the values are coming from my value 2. So that's pretty self-explanatory, I think. Okay, so now we need to do a series of annotations that we do that through the arrow function. A blue trend line is going to be plotted at 45% with black ends for aesthetic reasons. Then the line is going to be labeled as all values in percent. Let me clean this thing. Okay. Oh, I should have done it. Okay. There we go. And it's going to be that thing is going to be positioned at the top right. Then we've got the statement where we set the font to 3 in here, which is causes an italic font. Phonico 4 is going to set it to a bold one if you wanted to create something bold. But in here we want something italic. On the previous line with the text, what was that text there? That text is just 45. 45 is going to be bold, and all values in percent is going to be italic. Then we've got we set the XPD equal true in order to enable plotting outside the chart area. Then labeling of the value axis is done using the mtext function in here. And we are, it basically requires a specification of the values that are to be plotted and their positions, which we are passing to it. And then at the very end, the title and the subtitle are going to be plotted, and the source to be plotted below the chart. And once again, we are going to use that mtext for all of those. And then dev off would basically close the file for us, and we can see that PDF file. Now, let's go to here. And hold on a second. Let me change what I'm sharing on the screen. Okay, now I just need to bring this in here. All right. This is going to be like a torture. Let me bring it back here first. Okay, we are exactly where we want it to be. So this is ridiculousness, so small. What should we do? There's no way that we can do anything with this. Let's go to here and set the working directory with this. Then
I think if you do view the actual size,
yay! You're a genius.
I just have to open
All right. Also, I want to do this. Now that I am doing that, okay. Now everything is okay. So if I go and run these two lines, what it's going to do is going to create this in a PDF file. I'm not going to do that. Instead, I want you to see step by step what's going to happen. So I'm going to come here and start from this line 99 to set up the page. That's done. Then I'm importing this library called gdata. Then I'm reading the Ipsos file. I can say view is it Ipsos? So if you look at Ipsos, it has the name of the countries and person, nothing else. It's very simple, okay? So then I'm gonna sort it and I'm gonna attach Ipsos, sort Ipsos. So if I look at view, so this is the sort Ipsos start with China and the Ipsos start with Indonesia, okay? So it's clearly sorted out now. Now I'm going to create the first bar plot, which is going to give us this. We are going to add the text and the colors for Germany and Brazil. Then we are going to add our shaded rectangles. And you can see one by one, it's coming on top of the existing one. Then I'm setting my value on my color too. And then I'm gonna relay those on the current bar chart. And it's gonna give me these two magenta lines. Then I'm gonna go through the arrows and I'm gonna add the extra small arrows that we need in here. Then I need to put that 45%, average 45, and all values in percent coming here. Then I just need to add this text with all the x-axis margins, bins. Then I just need to add those other decorative stuff on bottom and top of it. Okay, and it will regenerate what we were after. Now, I don't have the file in here, but I'm going to regenerate the whole thing again. But this time, I'm going to use the whole script. So it basically go ahead and create the PDF file for me. So I'm going to do that one more time. It already did create it. It's here. No, sorry, not this one. This one. It is here. It's already created, but I forgot to clean up this one. I just want to show you that it's not going to create any output on the screen for me. So the other problem is I am actually also going through the next one. So that's it. It didn't create anything in here, but it did create the bar chart for me. All right. And this is exactly the thing that we had on the screen. Now let's go back. Any questions so far? All right. Let's go and oh, come on. Let's go and come back to here, and then I need to do extend. All right, then all right. These are some other examples of a bar chart that you could generate. Uh, you can find codes for each of these on that link for the disclosure, the book that I put. But if you couldn't find it, let me know if you are interested. I probably have the code for them. But let's look at this one. This is another one. It shows the number of links to home pages of a statistical software as a column chart for illustrative purposes. But the issue in here is that the labels would be too long here and would overlap. So alternatively, the bar would have to be a space far apart. So the figure would not basically look nice if you were to do that. So we've got a couple of options in here. One of them is we organize our labels either in two rows or on some sort of 45-degree angle. The other one is that the chart was purposefully kept simple and follows the reduced appearance proposed by the Edward Taft. So with bar chart, we should go without grid lines and rather break the columns with white lines. Once more, there are no aspect ratio resulting from the presented numbers. Sometimes the size and ratio has to be chosen depending on the page layout. That should be the exception though. If the figure is embedded in a text, then an aspect ratio of something like, for example, 7:5 is going to be a good one. With two-line labeling of the x-axis, the individual labels should basically obviously not be too long. In this case, this does not pose any problem for us because the labels are quite small. Since the largest column is against the y-axis and the columns are visually subdivided, we can basically do without tick marks on the axis. So usually when you've got values that exceed 1,000, then we usually put a comma after 1,000. So you see all of these having a comma added to them. And the common use of a space instead of a comma, especially in official statistical publications, is generally less suited for figures. So they usually don't do that. Here is the script. This is quite simplistic. We directly define the aspect ratio of 7:5, and then the procedure of the data import and sorting is exactly the same as before. So we are reading the data from this file, and then we are attaching links, which is this XLS table. Then we are sorting it against based on the number column. And then we separate two variables, my name and numbers. My name representing the software name and number representing the number column. So just one thing, when we put a minus in here, we actually force this to do a descending sort rather than ascending. So that's why there is a minus present in there. And the other thing is, because we want to use two-line labeling, then we are basically using this library called Plotrix. This was developed by Jim Lemon. Now let's take a look at the rest of it. So this package would basically provide the extended bar plot function, which is called bar p. And And it also provides another one called StackSlab function that would allow multiple lines of access labels. Uh, that's here. Then the BARP arguments largely match those of the bar plot. It is important to set the stacks to true. Otherwise, it wouldn't expect you to pass this. So whenever you do that, it does not output any x-axis labeling, but leaves these to the subsequent StackSlab function call. We only have to specify that the parameters refer to axis 1 or x-axis. The position of the labels are going to be from 1 to length of the names. That is going to be in here. The names are going to be my names variable we generated in the previous line in here, which is the software names. So that's that. Number of rows are equal to 2, and finally the distance between the axis and the first row is set to 0.75 in here. Then we've got this parameter called big.mark equal comma character. This would basically regenerate the 1000 separator comma for us. Then what else is here? I don't see anything important in here anymore. We also set the beginning, we set the power to BFG. Sorry, we set the, it was here. Here, FG power to BG when we were setting the environment for ourselves. That would basically help us to hide the line and x-axis labels that the BARP function are going to draw by default. So that's a way to get rid of those. A specification of the background color using FG also impacts on the StackSlab function. So we now have to again set the color using the call equal black. Really, that's it. Let's take a look at the code and run it together. Let me see. I'm going to limiting. There we go. And I'm gonna go to here in our studio, and I need to convert this to duplicate. All right. So we are here. I'm gonna install the Plotrix. Then I'm gonna load it to the memory, load GData again, set the environment using the par. Then I'm gonna read the file, put all of it into links. If I view links, it's gonna look like this, very simplistic. A software and a number. Then we are gonna attach links. I'm gonna sort it, and I don't think we needed to attach it. And then I'm gonna read my names and my number. How much time do we have? Oh my God. And here I'm creating the bar plot. Then I'm again setting par to call equal black, using StackSlab to create the labels down here. Then I'm setting the lines, the horizontal lines of white, and then just putting the extra text here and there, and this is done. Let's quickly go to the last one. Where is it? What is here? Okay, and so these are some other examples of R-based graphics that you can easily draw. They look pretty, but they're quite simplistic. Another one is something like this. So with bar chart, there is also the option to show shares. However, there is one thing to be mindful of in the commonly used illustrations from the stacked areas. A share cannot be distinguished from an addition without further explanation. So in these cases, it makes sense not to use the entire width of the bar or the columns for the presentation of the share, but only use half of it. And this is what you see in here. In order to maintain the proportion, the height of this area has to be doubled. So this example shows an installation from the for the sum of requested and granted applications for research grants submitted to German Research Foundation called DFG. And it is being split into 4 scientific sectors. Since the grant amounts are real parts of the resources that are being requested, no €1 that wasn't requested is actually being granted in here. In the figure, the column height reflects the amount requested, and the lower area, the fraction of the amount that was granted. For better orientation, the respective sums are written inside the columns, and the grant rates are basically presented over the columns. The figure's essential message are that the grant rates are almost identical across all 4 science sectors, and that significantly more is requested and therefore also granted in the life science than in any other sector. And you can get this from DFG Information Cards 2011 if you were interested to get the data. But this is the code for it. Again, very simplistic. The script first embeds the data, the first four colors twice, then the actual data, and finally the labels. So that's it. It basically double presents the data in the beginning. So you can see that the values are being repeated. We've got two NYC1A, then 2 NYC2A, and C3A, and C4A. Then after that, so that's the first bar plot that it creates. And then after that, it actually creates the actual bar plot, which is C1A, C1B, C2A, C2B, C3B. Sorry, that is supposed to be C3A, C3B. I somehow made a mistake when I wrote that. and then C4A, C4B. So note that the application sums are read twice. This makes the bars twice as wide. The grant data, on the other hand, are only read once. The respective first values are set to 0. This is followed by 2 bar plots cards. Since we do not set horizontal equal to true this time, then we are not going to have bar but column charts in a set. And the second call is done with add equal true in here. So it would basically put this on top of the previous one instead of redrawing everything, cleaning up the screen and redrawing a new one. To maintain correct proportion, grant data y have to be multiplied by 2. Alternatively, column width could have been adjusted accordingly within the bar plots calls. And at the end, we have 4 times 3 labels. Halfway up, the values of the requested and grant sums, respectively, centrally over the columns, the ratio of granted to requested sum in percent. And then the term that we've got in here, format round x1i1 and n small equal 1 at just equal 0, that ensures output of a decimal place even with integers. So let's take a look at this very quickly. There we go. And I am gonna put this on here. That's it. Okay, so not that one, this one. Okay, let's clean this thing up. I'm reading the data in here, setting the first bar plot. This is the one that has multiple. Then I just corrected my code in here. Make sure that you correct that for yourself, otherwise you might get something. Oh, well, seems like it didn't matter. The data is the same. Okay, then setting the z to -1 and putting the text up. These are all the percentages added to it, and then adding the cosmetic text here and there, and we are done. Any questions? No? All right. So I already uploaded this to Canvas. You already have the slides in Canvas, I think. You should. But I'm gonna check, and if you don't, I'm gonna add it. But that's it. There is another one with the pie chart that you can also take a look at that. That one, unlike all of these, would basically set the names of the variable with whatever it wants to print on the y-axis. And when the bar plots, when you pass that variable into the bar plot, into the pie chart, it will automatically put all of those values on. Okay, so you might want to take a look at that and see how useful the names attribute is going to be when you're drawing this stuff. Any questions? Make sense? All right. So we are going to continue next week with ggplot2. I'm not going to go through the pie chart anymore. If you have any questions, send me an email. Let's sit together, go through it. Otherwise, this is it on the base graph. We are going to go through ggplot2 and spend hopefully 2, maximum 3 sessions. And then I'm going to release homework 3 for you, which is going to be on the difference between these two. Okay? Have a good day, everyone.
Thank you for the extension.
No worries. Bye, everyone.